Let's move on to the next uh, hands-on mini project. All right, so what we want to do is let's build a uh, deep neural network using the CNNs uh, to get what is called as the blood cell analysis. All right, I got a data set of various types of blood cells. Right, so we want to build a system using the deep learning technique, okay, so that we can classify the images. All right, so you can see here I have created a folder over here which consists of four types of uh, can you see now? So blood cell analysis is the main folder. Okay, inside that I have a database which consists of wherein actually we can see four folders, right? So in Matlab it is pretty easy. I don't have to take care of each and every name of the file. Okay, you can name the data set file by any name. Okay, you can give name anything, but you put it in a folder in such a way that the folder name is the class. Okay, so you can see here one type of blood cell is called as echinocytes. I'll show you the image. You can see here, right, on the left hand side. So the image says that the blood cells are not they don't have a proper shape. You can see that they have some edges. Okay, it's not smooth edge over here, right? So look carefully. So that anyway, I'm going to show this later, but just now I want to show you the various classes of data we have. The second one is elliptocytes. As the name suggests, the class shows images where the image the each blood cell is like an ellipse, right? Normally the blood cell should be right round, right? So circular in shape, right? Just check any class, any data you have here, right? We have a large number of data set. Everywhere you can see that it's elliptic, right? So collected the data, but data, the name of the file should not match to the class at all, right? But put them in carefully. We should put them inside the folder such a way that folder name is the class name. All right, then you see this particular folder contains the normal blood cells. You can see properly, right? Circular. Can you see? Right. So that's the class called normal cells. Then there is another uh, abnormal cell called as a sickle cell, right? So if again something like each of the blood cell is only 60 to 70% proper, remaining part is teared off, so it's no more circular, it's not in any shape. All right, so that particular class is what we call as sickle cell. It causes a serious disease called sickle cell anemia. All right, so now by just looking at the blood cell, we want to classify that, okay, this particular blood cell belongs to a specific class. All right, so we want to do that. We'll write a code for that. Okay, so I'll let's go back to this in the blood cell analysis part. Okay, so okay, first let's create the required file. All right, uh, we'll use the functions at a later stage. Okay, edit, and we'll call the name. We'll call the file by a name, that is blood cell classification. All right, so that opens a new thing here. Now, as usual, we'll start with the first part of first section, which simply the closure of every other unwanted window, which is from the previous sections. Okay, then it's a clear PLC. Okay, so let's run the section so that everything is clearer, and I'll go for a sectional break. So in the next section, I need to read the data. Okay, so data is located at a particular file. So, sorry, particular folder, and inside the folder we have many subfolders. So I have to specify the complete data path, right? So I'll define a variable. Okay, so that is the path of the data set. Okay, so data set path is equal to, so if you remember, you can define that. Let me go through this. Okay, let me open this. Yeah, till here I need this. So don't go inside this particular four of the folders which contains the data set, but just tell me where do you have the four different data sets. Okay, four different classes, where they are located. Copy that. Okay, so and paste it over here as your database. That's a data. Okay, then I need to go back because I'm running this file. So you should run where the file is located, where your the script file is located. So this is just, I'm saying that dataset path is like this. That's all. Okay, so I'll go to end and I'll press this. Okay, so dataset path is defined. Now you tell me where I convert the dataset path into a data. Okay, so anyway, I'll just write my data. So this is the image data. How do you create image data? I think we have already used this concept once. What is called as a image data store. Do you remember? Image data store. No, I'm not defining a layer yet. Okay, we'll go to the layer later. This is actually image data store, uh, which, so if after I run this, once I create the data store and I run this, the my data comes into workspace. When I open that, I'm going to get the file paths of each and every file that is present in the form of my data set. Okay, I'll show you that. Okay, we use this once, but right, just try to recall. All right, okay, so I have to say that where is it located. You can see that it is asking for the location, right? What is the location? Location is nothing but the data set path. So as you enter, it suggests, right? So it's easy to type also. Okay, come on, now you have the options. Okay, options are nothing but, right, what are the options you have, right? So I can say that include the subfolders, right? Just say them too. It suggests what you can. Okay, so I'll go to the next line. Then yeah, then I don't want to go for file extension. I don't want to this. I want to say that label the source. So what are the right labels of each class? It's the folder names. Can you see it suggests that folder name? Okay, that's all. So I just want to do this. Anyway, you can actually explore what are the other options we have. I just want to say that include even the subfolders of that locations, whatever you see over there. I have four different files, sorry, four different folders, and inside the folders you may have even subfolders, but doesn't matter, include everything. Okay, that's what I'm saying. And class is defined, label the source in the folder name form. Whatever you see as the folder name, you have to use it. All right, so that is what is the meaning of this particular command. All right, okay, then okay, now you see, I'll go back and I'll show you one more thing related to the data set. Okay, so look at the first image. You see the size. As soon as I click on that, it shows the size 867 into, I'll show that it says only for some time. Quickly look at that, 500 into 402, 867 into 539. You can see that right on the left side. You see here, just before it loads, it actually shows the size. So one thing I should understand here is that size of each of the image is different. They are not same. So it's true for each and every class. Okay, so every class data, you can see that there are varieties of, right, what you call, the sizes are different, right? But our, if you try to give different sizes every time, right, it becomes difficult for any machine to, right, adapt to that changes instantaneously. All right, so you're understanding the problem, right? So what we can do here is that the suggested method is this. So whenever you are trying to say create, right, a deep neural network for image processing, we have, it's better if you fix your image size. All right, So I'll define a variable now. I'll show how to use this later. Okay, but what's the reason I'm using the image size? It's because I want to keep the image sizes of my complete data set to the same value. Okay, I don't want to have a change value. So image size should be equal to, you see, we'll create an array. How many rows, how many columns, and how many pages, because image is color, right? Just now you saw the images are color images, right? So you need third dimension. So let me fix it. So 300 rows, 400 columns, and 3 RGB. So 3. I hope you are fine with this. Okay, let me know if you have any doubt. Okay, so that's why I defined the image size, right? Okay, so in the next line, uh, you see, I had an image store, but this image data store contains images of various types. Correct. Now you see, I need to convert each and every image in that image data store into a fixed size image data store. All the images should be of the same size, whatever I define. That is 300, 400, 3. So to convert that, right, I have another built-in function available, but first let me create the name for the this whatever data store. So I'll call it as, so the process, strictly talking about the image processing steps, right? The change in the size of your image, right? If the image is larger than 300, 403, you simply can cut the image, okay? But the image is smaller, then I am calling that, I'm trying to perform what is called as augmentation. All right, so the process is augmentation. So I'll call it as the augmented. It's, you see, it's suggesting the name augmented. Okay, that's a function, so I cannot use as it is because, right, machine gets confused. So I'll simply call it augmented data, right? So augmented data is equal to the augmented data store is the function. All right, I'm converting, right, whichever image, whatever size we declared. So okay, it suggests this particular size, and which is the data? It's my data, right? Because my data is the image data store, but that consists of what you say, right? That consists of various data sizes. I don't want that. I want all of them to be of the same size. Okay, so that's augmented data. Now you see, actually this takes a lot of space, right? So I'm not going to use this anymore. My data I will never use. I will use augmented data now on. So I can actually clear this just to save some space. You see, clear, actually, you see, I use clear at the top. That clear clears everything. I'm not specifying which specific uh, variables to be cleared, but now I cannot use simply clear because it clears out everything. I don't want that. I want to clear only this one, my data. Okay, which my data was created here, and I converted that into augmented data now. So my data is of no use for it. Okay, are you fine with that? Okay, right. So let's give a section break and let's run this section. All right, so on the left hand side, you can see, right, I have augmented data, data set path, and the image size. The image size is 300, 403. Data set path is what will be given. I want to show you what is this augmented data. Okay, let's click on there, right? So it actually reads, right, what, how many observations you have. So it says there are, it creates a cell. So we can see the details. It holds the address of, okay, this is, address is pretty big. Okay, so it actually, you can see here like this. So under the echinocytes, image 1, echinocytes, image 2, like that. All the echinocytes are completed. Then you can see the elliptocytes, right? Then you have the normal cells, right? Then you have sickle cells, etc. Okay, so I could gather a small database only, right? This is collected directly from the Google sites or something. right? I don't have a huge data set, but in order to understand the process, this data set is enough. But anyway, I will share you the code as well as this data set. So when you run, you try to add a few more. If you have access to any hospital database or any medical test centers where people collect the data, if you get an access, you can collect more, like thousands of data, and put it into this cells. That's all. Okay, each of the folder you simply put that category. No restriction on number. I just have I may have just 10 to 15 in each of the class. You simply add thousands to each class, automatically it will take care. Okay, you don't have to make changes in any part of the code. Okay, right, only increase the number of this data set, so that data set it becomes improvised and there is more learning. Okay, all right. So that's the second part. So we have declared this thing, we cleared the data as well. Okay, the data set is ready. You don't have to do anything, right? Since it is a convolutional neural network, even the extraction of the features is not required. Okay, simply let's okay, so let's quickly do what is called as okay. So let's define the layers then. Okay, layers is equal to yeah. Now you said earlier that the images are given as input for the first. If you want to give images as input to the neural network, you have to use a layer called as image input layer. Correct? Image input layer. Oh, sorry. Image input layer. I have to specify what is the size, right? You see, it says that input size. Input size is image size, right? And let me even give a name for that. Okay, name. So what's the name I want to give? I will say very simple, like input input layer. Okay, let's proceed further. Next, I want to start with the CNN, that is convolutional layer. Since image is your data, so the convolutional layer should be in 2 dimensions, correct? So as you can type, it comes here there. So convolutional 2D layer. Okay. So what are the requirements? I have to tell what is the size of the filter. So let's say this is 3 cross 3. All right. Even you can work with 5 cross 5, 7. Normally some odd orders are used. Okay, but there is no specific reason for that. You can even go for 4 into 4, 2 into 2, etc. Okay, right. Then how many such filters you want to use? Right, that's what is required. So I'll try to say 32 filters. Then you should use an option called not bias. I'll go with the say padding. Let's define the padding. So padding equal to uh, just padding equal to say 1. Let's see what happens. Then I want to give the name. Name is equal to, what's the name of this layer? Say this is a convolution layer, so I'll write conv 2 and sorry 2D, right? This is the first layer. Okay, first convolutional layer of 2 dimension. Okay, then we'll go for a patch normalization. Let's try to recall the order of layers we had studied, right, when we discussed the theory part. Okay, or also the previously discussed mini project where we have used this, right? So similar order I'm using here. Okay, after a convolutional 2D layer, I'm going to use a batch normalization layer. Okay, so the batch normalization layer. Actually, you see, you don't have to specify any other parameter. Simply, you can define the name that you want. Okay, so the name will be, so this is batch normalization 1. Right, so I want maybe we'll use a double quote itself, because I think it may generate an error if I don't use that. Okay, so name, use a comma. That was the that is standard way. All right, so name batch norm 1. Move name arguments, name equal to value at the end of this. Let me check later. All right, no problem. So then so we need an activation, right, at the end of one set of layers. So input will give the data to the hidden layers, starting with the convolutional 2D layer, passes on to the batch normalization. Now you need to activate, right? So neurons should activate. So in CNN, which is the activation function? It is ReLU. All right. So use a ReLU layer. So specify the name, comma. So I want to tell what's the name. Let's define the name as ReLU. Okay. So ReLU is over. Now once you have the output of value, it is suggested to make a pooling, right? So I should use a pooling layer. If you remember, we have two types of pooling possible. Right? Normally used pooling layers are, one is a max pooling layer and another one is the mean pooling layer. You can go for any one of them. So I prefer going to the max just to hold the highest values, right? So max, if you write p, it says max pooling layer, so I'll go for a 2D layer, because data set is 2D, everything will be in the 2 dimension, right? If you remember, I have to say what is the pooling size. So pooling size will be 2 cross 2, right? 2 cross 2 in the sense, consider 4 different inputs to this layer, pick one of them. Okay, so max pooling layer of pool size equal to this. Okay, then we have the stride. Okay, how much shift you want to give after you consider 4 points. I should shift to right or downwards by 2 units. Okay, so that's why it is stride. So stride size is 2. Shift to right or left by 2. Okay, then I'll go to the name part, and let's say the name we want to give here is the max pooling layer number 1. All right, so the pooling is over. So this is one set of the hidden layers. But right, since it is image data set, remember one type will not work usually. So you have to go for a second set. All right. So the second set, okay, let me try to write the next set of layers. Right. Once again, I need to go for a convolution. It should be convolution 2D layer. Convolution 2D layer. already used a 3 cross 32. So normally when you write the second set of layers, or when you repeat the layer, you should double. Okay, size will remain same, but the number of filters you have to increase. This is the common way of writing. Okay, then I need to say that, do you need padding? Right, so padding, right, I will write 1. Okay, that's the padding requirement, and I'll say what is the name. So what should be the name? Right, it's a convolutional 2D layer. So whatever name I gave earlier, I'll add a next number to that. Okay, so that is con 2D. It's a second layer. Oh, sorry, 2. So convolutional layer is defined. As you can see above, followed by I need to use a batch normal. Okay, so batch normalization layer of, so again nothing to specify like the parameter, simply define what name you want to give. Okay, so batch nor 2, that is batch normalization second. All right, after the batch normalization, right, will activate, right, by using the ReLU layer. Specify the name equal to, I think I have given ReLU 1 earlier, so I'll give say ReLU 2. Okay, ReLU is done. Let me, I think to since the size of my images are not very huge, okay, not like HD quality, it's very compared to the large sized images. This data set what we are considering has lesser number of data points, pixels are less. So because of that reason, I think 2 layers are sufficient. What we do, we'll try. Okay, we'll run the whole code with this, and if the, what you call, time required, or if the accuracy is not, say, accuracy is not very good, then we will make changes in this particular set. Okay, right. So after this ReLU, I should go for output layer. Final output should be 4 classes, right? Because we have 4 images, 4 classes in our images. So use a fully connected. So fully connected layer, it takes the inputs like what are the outputs you want. I have 4 classes, right? So the output size is equal to 4. And you can have the options, right? I will directly go for the name part. I don't, you see, you have actually these many options. Okay, right? Just explore what they are using the help, right? But you don't have, it's not necessary to use everything. But since I want to give a name, I'll add a name. Okay, so that is, it's fully connected. Then output layer is activated by the softmax layer. Use that softmax layer and simply specify the name. That's all. Okay, name softmax. Right. Then this is actually, I have to specify one more thing at the end. Are you doing a classification or you are doing the regression? Right. You need to specify that. So I'll go for the classification layer. Yes, you can see that. Okay. So I'll just specify one thing here, that is just a name. Okay, name equals to the output layer. So this is done. I think we try to run this. Okay, there is something. So unsupported use of equal to. Oh, that's this thing, I guess. So let me check with this. Adding. Come on. Right, let me just check once again. Yeah, it runs. So layers are defined like this. So once the layers are defined, I will give the options. Okay, so using the options, I can tell how I want to proceed with the training. So uh, let's go with the options equal to what is the command to give the training options? It's training options to train a deep neural network. Right, so these are the most commonly used options you have. I'll go with the LM. Okay, then these, you see, these are the all options we have, right? One by one you can give, right? So let's first go with the max epochs, right? So I'll enter max epochs, let's say maybe, let's start with a smaller value, so 50. If it is not sufficient, we'll do that. Okay, then I want to say what is the minimum batch size. So let's keep the batch size as a 10. Okay, mini batch size. Then I want to say that right, validation data, right, that should be the augmented data itself. Okay, it suggests that, you see, it's pretty good. Augmented data in a sense, whatever I have done that, right? So do a validation with those, right? Then I can go for a validation frequency, right? Every time you learn, you try to do a validation. That's why validation frequency I keep as 1. Okay, then yeah, so many options you have. We don't want to use everything. Let's go for the shuffle, right? Shuffle every epoch. I want to shuffle after every epoch. That's it. So 50 epochs have been used. So that means I have to, right, repeat so many times, 50 times, right? Then let's go for a verbose, right? You can say that true or false, right? That is true. I want to see that the outputs, and the verbose frequency can also be uh, any value we set. I'll keep it as 1 every time you update, right? Show me that. And definitely I need a, right, so either you don't want to see or you want to see, that's all. You have only have one option, right? So then let me check what we can do. Learning rate output network. No, I don't want to. Okay, let's give an initial learning rate. Initial learning rate we can keep as a 0.0001. All right, so we'll keep it very small. It learns slowly. Okay, 0.001. Okay, then no, I don't want to use validation. Patience, regularization. I want to see the execution environment. Okay, right? If you have a GPU, you can use the GPU. If you don't have GPU, right? You can keep it auto, right? If we are not sure whether we have a GPU or not, we can do that. Okay, parallel is also possible. Like it uses parallel pools to do that, right? Whenever we have multi-core what you call CPUs or GPUs, you can use that. Multi GPU is also a similar option, but I will go with the what, right? Right. Okay, I think we defined pretty much required. Let me just run this and see. Okay, that works, right? Options have been created over there. So let's go to the a section break. All right, then whatever we have plotted earlier, I'll simply clear. So clear screen, that's all. Okay, then okay, let me not clear. We are plotting. No, we are not plotting anything, but still, okay. This CLC I don't. Let me call, right? How do you see the layer graphs? It's by using a function called layer graph. I'll call it as L graph should be equal to the layer graph. Call this function layer graph of, right? What layer we have already defined as this, but it will not show you that until you call a figure. All right, call the figure and ask it to plot the graph we defined. Okay, so that is uh, L graph. Okay, so let's try to run this section. It's still running, and I think you can see the layer graph created, right? So that gives you the complete details of, right, the layers created, right? Input, convolutional 2D layer, right? Batch normalization, etc. All the layers we defined, right, in the layers section, we can see here, right? So that's the layer graph part. So you also have a complete details over here, layer graph. Right. So anyway, so I can even open the layer graph here just to see the number of layers defined, right? I think the details are available if you click over there. What is the activation function used, right? How many channels are there, right? What is the padding size, right? What's the name of the input to this, output to this, etc. Everything is visible. You can check that for each and every layer we defined so far. Okay, so the ReLU is also there. ReLU 1, input is something, output is something, number of outputs, etc. Everything you can see. All right, so that's the use of what is called as the word layer graph. You can visualize, or you can see that by clicking the variable name in the workspace. So add a section break. I'll move ahead, and here I'll perform the training part. Okay, so what I do, I'll clear the screen just once, then I go for a network. So net is equal to, so train the network. I want to train, which is your data. It's the augmented data, and use the layers and the options. Okay, so let's do the training and see what happens. Okay, it is initializing. It might take some time, okay? But as soon as we see the uh, verbose starting up, we'll see a table coming in this command window. Yeah, as you can see, it started. Okay, just started. So what I do, I'll also try to bring the training progress window so that we can trace what exactly is happening. Every time it trains, it also performs what is called as a validation. So you can see that validation is happening for every training cycle. So you can actually reduce this if you want. You can keep as 10. So after 10 training sessions, it will do one validation. That's also fine. But if you want to have a better training, you can keep it as 1, 2, or 5 or something. But anyway, according to the number you enter, the time required for the training will vary. As we can see here, the validation accuracy is close to 90, 95 or something. Okay, it even reached 98, we can see, but it's fluctuating. All right, 96 or something. Let's see what we get at the very last iteration. That will be the final value of the validation. Okay, so we can see here the final results of training we have. Okay, it says that validation accuracy is 96.3%. And since we reach the maximum number of epochs, the training stops. And we can see the total time taken using a GPU is 5 minutes 26 seconds. Okay, and yeah, so other details also we can see. All right. Okay, so as we can see here, we could finish the complete training part. All right. So now we'll try to perform, let's say, the testing. Let's go to the testing part. We have a section break, and let me even whatever I have on the screen. Let me try to clear that. And the y predicted value. The predicted value from the machine is classified. Okay, so yeah, so this is classified. Use the trained network, and I also have to say, right, which particular data set I want to use. That's the augmented data itself. Okay, so that finishes the testing part. Then I want to have the comparison with the actual data and the predicted data, correct? So let's read that from the data and its information. I can read, all right, from the read command. Okay, read of the augmented data. From there I'm reading this. Now I'll calculate the accuracy. So okay, accuracy. So it's not a built-in command, so I can use it. Okay, so it's 100 into I'm converting into the percentage. Okay, so that is 100 into sum of wherever you see that the y predicted being equal to the information you gathered dot, right, it's called as a label. Wherever the names match, I'm going to get this. Okay, this equal to, so I should perform dot divided by the numerical length of the info dot lib. All right, so let's check this. Let me run this part and see. I'll save it. So 96.29% is the accuracy of this model which we have. Okay, so this is one part. Only what we could do now is that we built a model and we tested the model. Okay, which training is also over. But in this case, I want to go one step ahead, and in the upcoming session, I'll show you how to visualize the various weights of this network, because this network has a lot of weights, right? Each of the weight I will try to show. Okay, so how to check that? I will maybe we'll see that in the next class.